that Schoology thing we did last week, I want to make sure you're totally legit knowing how to do that. We will do a one-page pencil paper quiz tomorrow. Okay? But I want to make sure you're good with that. And then I have another thing I'm going to teach, but the thing I'm going to teach is not going to be on the little one page. And the only reason is one page, not half page. I wanted to give you a little bit of room. But that's basically it. So I want to jump on to Schoology, and I want to make sure that you feel comfortable. I mean, I know you all did fine with this, but I also know that you were helping each other, which is great. I didn't discourage you from it. I wanted you to work with each other. But tomorrow's, one page, front side only, is going to be there. So let's just make sure we feel comfortable with this. Courses, business calc. And the chapter 5 test is what it was. So let's just make sure we feel totally good and make sure that we can do it. So if you wanted to jot down notes or just kind of be like, I got this, Stirrup, it's your choice. All right, so basically we have this, and I want to just go over just so you feel comfortable, making sure you know what's taking place. I got -1, I got 1, I got 2, and I got 3. And I got negative, positive, negative, positive, positive. Okay? And don't worry, tomorrow isn't going to be matching up the graph, but I just wanted you to feel comfortable with what we have on this particular problem. So this is a derivative chart. 1, 1, 2, and 3. And they told us over here it's negative, here it's positive, here it's negative, here it's positive, positive. Okay, so the sign changing is the vital part of this. Agree? But if the sign stays the same, that's also important. So the -1, the 1, the 2, and the 3, how these would have taken place is if I knew the original function and took the derivative and set the derivative equal to 0, that's where those numbers would come from. Does that make sense? And it's okay that you don't, I know you're fine with the derivative, but I'm okay that you're not able to always find -1, 1, 2, and 3, or whatever the numbers are. So I want you to think about a few things. This means that we would have a negative slope to a positive slope. So what would this -1 be? What would you refer to it as? A max, a min, or a point of inflection? Yeah, this is a min. And then because we're coming up, this is positive, then it goes to negative. What's happening here? That is a max. And then we go negative back to positive. This is another min. And then if it goes positive to positive, what is this known as? Point of inflection. And so if you guys just got here, we're running through the quiz that we did. I want to make sure you feel good. You have a one-sheet, front-side only quiz tomorrow to make sure you know how to do this. So if you are able to identify those types of things, you're going to do just fine on one of the questions on the quiz tomorrow. One-sided sheet of paper. Okay? Is there any questions on how that information would have been generated, or do you feel comfortable with what we have? Good. Here come few. Hello, hello, hello. Only 3 hellos. Oh, I appreciate the hello back. Let's see. And what we're doing, my friends that just came in, we're going over the Schoology quiz to make sure we feel comfortable with it, because you'll have a pencil paper one-sided version tomorrow. Okay, so this is the first question. Is there anything about that? If I give you an F prime chart, all I'd want you to say is max, min, or point of inflection. So hey, can a point of inflection take place when I have negative, negative in a row? if I had this, and I knew that I had 3 and I had negative, negative, does that also create a point of inflection? Yeah. Okay. So if the sign stays the same in between the left side and the right side of a critical point, and the critical points in this case are -1, 1, 2, and 3, then we have some information that'll be helpful for you. Okay. All right. All right, let's take a look at the next question on this quiz, just to make sure, or this thing we worked on the other day. Number 2. All right. If you set the derivative equal to 0 and solve for x, your variables, then you find the roots. So if you set the derivative equal to 0, you find the roots. So if I did this, if this is set equal to 0, does this find the roots? Yes or no? It is a no. So this is no. F prime set equal to 0 finds the critical values, and that's where max, min, and point of inflection take place. Okay? So just note this. If you set the original function equal to 0, so the original function, this is how you would find the roots or the solutions to the problem. And it's big that you know the difference between the two. Okay? So yes, you can set the derivative equal to 0. That's great. But the derivative set equal to 0 does not find you the roots right off there. Okay, everybody happy? All right. So let's go to, that one doesn't work on the screen. All right. So let's go to the next question, number 3. When you're looking at an F prime chart and you have a critical value at 7 in which the section left and the section right of 7 are both positive, you have a point of inflection at 7. So what this is basically saying is, go here. You have this. Come on, figure it out. Come on, stirrup. You have a 7, and it said they're both positive. I have positive on both sides. This is not a max or a min. It is a point of inflection. Inflection. That's FL. Okay? This could also both be negative and negative. If you have the same two signs on the left and the right side of a number, a critical value, that critical value is got because you set the derivative equal to 0. If that takes place, that means you have a point of inflection. A point of inflection, POI, is going to look something like this when we have a graph. So it's where your graph kind of flattens out, but it goes positive. It's positive all the way up, and then you have that value. You have this value here. So this is some number. But as long as it stays positive, 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 you get to that point. Basically, at that point, the tangent line is 0. But if it stays positive slope on both the left and the right side, then that means you have a point of inflection. Okay? And then I think the fourth question was, if F prime line has critical values at -3, 2, and 5. So let's write that. So let's make sure we can answer this question. So this is an F prime chart, and I have -3, 2, and 5. And this is positive, this is negative, this is negative, this is positive. What can you tell me about 3? It is a max. Okay, so think about what that would look like. It would look something like that. What is happening here at 2? Point of inflection. Signs didn't change. And then, so this went negative, then negative. And then what happens at 5? This is a minimum. And they call them local minimums or local maximums, but that's basically the ins and outs of everything that you've dealt with. Okay? Friends, do you feel comfortable with that?
Yeah.
All right. So, I am going to take a sheet of paper. Regular sheet of paper, yes?
Yes.
Now, all I'm going to do, this sheet of paper, we can measure the size. It's 8.5 by 11 as far as what I've ever done. I've never really measured it. But I'm going to rip out the same size, or the best sure we can, same size, corners out of each. This poor piece of paper, it did nothing to hurt us. Okay? So I just ripped the corners out so it kind of looks like a really bad version of a plus sign. Okay? And I'm going to fold up along the seam of each of those torn out corners. So what it basically does is it creates ourselves a box without a lid. Okay, does that make sense?
Mm-hmm.
Pretty simple. So let's put that right there. When the dryer comes, so you can play with that. Okay, so let's talk about what we did here. I'm going to draw in a rectangle. And that's a square. I don't want that one. A rectangle. And all I'm basically doing we're going to cut out the corner. Now I'm going to go copy, paste, and paste. Oops. Control V. Control V, Control V, Control V. Okay. Oops. No, I don't want that. Undo that. Go here. I'm going to take this, put it here. This, put it here. This one comes down here. Fix that one a little tiny bit. Yeah. Oh, sure. And then when I, oops, come on, baby. Come on down here. All right, now what I'm going to do is I'm going to draw myself a dotted line. And we're going to make this dotted line a neon green. So this is basically what I had just done. Looks a little neater with the digital stuff. So where those dotted lines are, I fold it up and I create a three-dimensional box out of this sheet of paper. Okay? So I know that this sheet of paper would have been 8.5 inches by 11 inches. And so what I want to do is I know that my sheet of paper, the area of my sheet of paper is length times width. Agree? The volume of the little box no lid, is going to be length times width times height. So height is going to be this little region here, each of these little regions. Okay? So what I want to do is I want to figure out how big of a corner do I have to take out of an 8.5 by 11 sheet of paper. It's a square. How much do I have to take out that would allow me to have the maximum volume of that box? Okay? Again, volume is length times width times height. Okay? So let's think about what this is. We're going to call H. We're going to make it X. Okay? So friends, how far is that red distance right there?
8.5 minus 2x.
8.5 minus 2x. Right. I pulled it out of each of the corners. Okay? So this is 8.5 minus 2x. That is what that length would be. What would this distance here be if I utilized my problem as well?
Are we using 11 minus 2x?
11 minus 2x. That means that my volume equation is 8.5 minus, I got to make some more room. Sorry. Can't have nice things. My volume equation is 8.5 minus 2x times 11 minus 2x times, I said that h is equal to x. So if I multiply this all together, which there's no reason to, if I multiply this all together, I would get an x to the third function. And an x to the third function kind of looks like this. Okay? So this is what an x to the third function is going to look like. So our graph is going to look like that a little bit. So let's jump on to Desmos and see what Desmos would be happy to deal with us. So we're going to just put in our volume equation. We're not multiplying anything out. So I'm just going to go y equals, well, y is going to represent volume. Volume is equal to 8.5 minus 2x, parentheses, 11 minus 2x times x. And let's darken this a little bit. Oops. Okay. So that's what my graph looks like. So if I find this vertex right here, that means that if my little square I cut out each corner is 1.585, so if my little tiny cut out of here, this right here is 1.585. Okay, so I cut 1.585 inches off of each corner. That means that my volume will be 66.148. Inches cubed. Okay, this is my maximum volume. Okay, now I'm not saying anyone will work here, but let's say you work at a box manufacturer plant, so you're getting flat pieces of cardboard. You have to figure out how to utilize the best of your material because waste material is money thrown away. So you could probably figure out how to start going through and figuring out some dimensions. Okay, so with that known, I truly feel that you have the opportunity to do the page that says index card optimization. And just realize you're using a 3-inch by 5-inch card. You don't have to have one. But I think if you do problems 1 through 5 on that page, and I'll mark that off tomorrow. And then what am I also doing tomorrow? What's going to happen tomorrow?
Quiz, 1-sheet quiz.
Yeah, the 1-sheet quiz. At the first part of this video, it went over the problems that you saw on Schoology. It's going to be very similar. It's one side of a sheet of paper. So this was Monday, 4/17, 1 through 5. Good to go? Can you handle it?
I think so.
We're one.